Good morning to all. Myself DR.K, Associate Professor, Department of Biomedical Engineering. Today class we are going to see about Introduction to 8051 Microcontroller. Today's topic we are going to discuss about applications of 8051 microcontroller, the difference between microprocessor and microcontroller, the 8051 basic component, the block diagram of 8051 and the features of 8051. First, the applications of microcontroller. In day-to-day life, we are using so many products that will be used made up of microcontrollers. So, some of the applications are keyboards, printers, video game players, MP3 music players, mobile phones, home appliances, data switches, automotive controls. The difference between microprocessor and microcontroller, it consists of CPU alone. The RAM, ROM, I/O, timer, interrupts are need to connect externally. In microcontroller, the CPU, RAM, ROM, I/O, timers, everything will be made up of a single chip. In microprocessor, the designer can decide the amount of RAM, ROM, I/O ports. In microcontroller, the fixed amount of on-chip RAM, ROM, I/O ports will be available. If they required, they can use externally higher size of RAM and ROMs. So microprocessor is an expensive, but if you take a microcontroller, it's a less expensive. If you take a microprocessor, it consumes more power. If you take a microcontroller, it consumes low power. Again, microprocessor, it occupies more space because we are connecting all the devices externally. And if you take a microcontroller, it occupies less space because in single chip itself, we have all the devices. Microprocessor, it's a general purpose device. If you take a microcontroller, it's a single purpose device. Look at this microprocessor. This is a general purpose microprocessor. It consists of only CPU. Look at this. It consists of general purpose microprocessor alone. This externally only we are going to connect this RAM, ROM, I/O ports, timer, serial ports. So whatever we are required, so we can connect externally to the CPU. So we can connect this data bus, bidirectional data bus will be used and unidirectional address bus will be used to connect all the devices. So it consists of no RAM or ROM anything. So automatically we need to interface externally alone. Even if you take a simple application like a blinking LED, without memory, RAM and ROM, it is not possible. So we need to interface RAM and ROM with this system. That's why the cost of the system and then size is very high. The examples of microprocessors are Intel 8086, Motorola 680X0. Look at this microcontroller. It is a smaller computer. It consists of all the peripherals. Look at this. This is a single chip. It consists of CPU, RAM, ROM, I/O ports, timer, serial COM ports. So, sufficient amount of sizes memories will be available. If they are not sufficient, they can go with this external RAM or ROM interfaces. So on-chip RAM, ROM, I/O ports will be available. If it is not sufficient, they can interface externally. They can use both internal and external RAM and ROMs. The examples of microcontrollers is Motorola 6811, Intel 8051, PIC 16X microcontrollers. Look at this 8051 basic component. It consists of internal 4 kilobyte ROM and 128 byte of internal RAM. 4 I/O ports will be available. Each port consists of 8 bits. So 4 into 8, 24 I/O pins will be available. The ports are port 0, port 1, port 2 and port 3. We are naming it. It consists of 2 16-bit timers and counter. We can use it a timer or counter, but at a time we can use only a timer or counter. So it consists of a 2 16-bit timer and counter available. One can be used as a timer and another can be used as a counter. It depends on the application. And it consists of one serial interface. So serially we can transmit and receive the data. So it supports a bidirectional supports. Full duplex bidirectional support will be available with this 8051 microcontroller. Look at the block diagram of 8051 microcontroller. Look at this. This is a CPU. It connected with oscillator. So this is the clock pulse will be given through this oscillator. So we have this oscillator and this capacitance will be connected. This will be given for a heart of the system. So it gives the clock pulses. Look at this external interrupt that will be connected to this interrupt control unit. So these interrupts will be connected to the CPU. Whenever external attention is needed, the interrupt will be given to the CPU. Look at this. This is the bus control unit. All the control signals, address bus, everything will be under the control of this bus control unit. Look at the memory spaces. So it have the on-chip 4 kilobyte ROM will be available. 128 byte of RAM will be available in on-chip. Look at this. It consists of 4 I/O ports, that is port 0, port 1, port 2, port 3, and each ports have a 8 I/O pins. So 4 into 8, 24 I/O lines will be available. Look at this. It consists of 2 timers. So both will be a 16-bit timers. So independently we can work with this timer 1 and timer 2. Look at the serial port. It has the serial port capability, full duplex. This is the TXT line. The data will be transmitted through this line. The received data will be received this RXT line. The features of 8051, only one on-chip oscillator we can connect it. So it have 6 interrupt sources, 2 external interrupts, 3 internal interrupts and reset. So totally 6 interrupt sources will be available. So 2 external interrupt 0 and interrupt 1, 3 internal interrupts that will be used for a timer 0, timer 1 and serial interrupt, 1 reset interrupt. And we have 64 kilobyte external code memory, that is a program memory can be interfaced by using this control signal PSEN, program stop enable. And 64 external data memory can be interfaced. It have a capability of both the read and write capability. So with this control signal of read bar and write bar. Code memory is selected by enable access, that is EA, internal or external memory. By using this EA line, we can select internal memory or external memories. We may have external memory as a data and code. So we can use a external data memory. Similarly, we can use a external code memory depending upon the applications.